Welcome to the Deep Dive. And this Deep Dive is presented by Samurai Kaizen.
I'm excited to be here.
I'm really glad you're here today.
Yeah.
Because we're diving into something that's absolutely exploding right now, the future of robotics.
Yeah.
But we're not talking about, like factory robots, those big arms welding things.
Right.
We're going way beyond that.
Yeah.
We're talking about how robots are going to be in your everyday life.
Yeah.
And I'm telling you, we've got research, news articles, we've even got some pretty wild speculation out there.
Oh, yeah. It's really fascinating where this is all headed.
Enough to make you rethink, everything you thought you knew about robots.
Totally. It's a whole new world.
Yeah.
It really is.
I've got to be honest with you, though, when I hear robot,
Yeah.
My brain still kind of goes to that classic image, like the humanoid robot you see in all the movies.
Yeah, I know what you mean.
But I'm getting the feeling that the reality is
It's much more diverse.
way more diverse. Yeah.
Yeah. It's not all about those humanoid forms that we're used to seeing.
Okay, so break it down for me. What's the real deal here?
Well, it's really about designing robots for very specific tasks.
Okay.
And that often leads to forms that are way more efficient and actually pretty elegant in a way, than trying to force a robot to fit into that human mold,
Right.
Like take autonomous delivery, for example.
Okay.
Companies like Starship Technologies, they're using these little sidewalk robots, right?
I've seen those.
Yeah. And Amazon is really leaning into drones to get those packages to your doorstep.
Yeah.
So why bother with arms and legs when wheels and rotors do the job just fine?
So it's about using the right tool for the job, even if the tool isn't a person.
Exactly.
Okay, I like that.
It's not about replacing humans, it's about finding the best way to get things done.
What other examples are there, that really break this mold we have in our heads?
Well, how about a robot that's soft and squishy, almost like a living creature?
Whoa. Okay, hold on. So we're not just talking metal and wires here. We're talking like a soft robot.
Yeah. Soft robotics is a really exciting field. A great example is this thing called the Octobot. It was developed at Harvard.
The Octobot.
Yeah, it's this inflatable robot.
An octopus robo?
It's inspired by an octopus.
Okay.
Designed for tasks that need a really delicate touch.
Okay, so what makes a soft robot better for these delicate tasks?
Well, think about picking a ripe tomato without squishing it.
Okay, yeah.
Or, assisting with surgery where you need to be incredibly precise and, not cause any damage.
Just like having a robotic hand that can conform to any shape.
Yeah, exactly. It can apply just the right amount of pressure, navigate through tight spaces.
That opens up a lot of possibilities.
Tons. In agriculture, medicine, even search and rescue.
Okay, now that's just cool. I mean, we're talking from delivering packages to doing surgery with these robots.
And that's just the beginning.
It's amazing. What about this thing I keep hearing about, swarm robotics?
Mm-hmm.
Is that related to these insect-inspired designs?
You got it. Swarm robotics takes its cues from nature.
Okay.
Particularly social insects, ants, bees, that sort of thing.
Right.
The idea is you create a whole bunch of small, relatively simple robots, and they all work together to achieve a common goal.
So it's not about one super smart robot, it's about a bunch of working together.
It's collective intelligence.
Okay, so paint me a picture here.
Well, imagine a swarm of tiny robots searching for survivors in a collapsed building after an earthquake.
Okay, yeah.
Each robot talks to the others, covers a vast area way faster than any single robot ever could.
Okay, so swarm robotics, this is a real thing. This isn't just sci-fi.
It's real. It's still early stages.
Okay.
But the potential is huge. We're already seeing prototypes of these swarm robots, and they're getting more sophisticated all the time.
So the robots themselves aren't necessarily getting smarter individually, but it's how they're working together that's making them more powerful.
Precisely. The whole is greater than the sum of its parts.
Okay. I'm already starting to feel like my mind is being blown a little bit here.
Yeah.
But before we go any further, I have to ask, we're talking about robots doing things like surgery, search and rescue.
Yeah.
Doesn't that bring up some ethical questions?
Oh, absolutely. We could easily spend a whole deep dive just talking about the ethics of all this.
Right.
But maybe for now, let's stick to the technology itself.
Okay.
Because even just the stuff that's making these robots tick is pretty mind-blowing.
Right.
We're talking about artificial intelligence, material science, even human-robot interaction.
Okay. Unpack that for me a little bit. When I think AI, I think, self-driving cars.
Sure.
How does that same kind of AI, translate into all these other robots we're talking about?
Well, think of AI as giving robots the ability to perceive the world around them, to learn, to make decisions, just like we do, but often in ways that we can't.
Okay.
Computer vision is huge. It's how robots like self-driving cars see, but it's also how those surgical robots navigate inside the human body, how drones know where to land.
So they're not just programmed for every possible situation, they're actually learning.
Exactly. And one really cool type of learning is called reinforcement learning.
Okay.
It's how robots learn through trial and error.
Oh, interesting.
Like you train a pet, you've probably seen those videos of Boston Dynamics Spot Robot, that dog-like robot, navigating all sorts of crazy terrain,
Right.
even getting pushed over and getting back up. That's reinforcement learning.
So they're becoming more adaptable, more,
Absolutely. They're able to handle those unpredictable situations, which is key if they're going to be out in the real world working alongside us.
So AI is making robots smarter, more adaptable. What about the robots themselves? Are there, like, new materials being used to build these things?
Material science is a game changer. We're talking about materials that are stronger, lighter, more flexible, and even self-healing.
Self-healing, wait. Like Wolverine-style self-healing.
Kind of. Think about it. A robot gets a small crack or puncture, and it can just repair itself like our skin does. Longer lifespan, more reliable, less maintenance, especially important in tough environments.
Okay, self-healing robots. I knew we were talking cutting edge, but that's next level.
And that's not all. There's graphene.
Graphene.
It's this incredible material, just one atom, thick but super strong, lightweight, and it conducts electricity really well.
Okay.
So we can use it for super sensitive sensors, efficient components.
Oh, so it's not just about being strong, it's about all these other properties that can be used in all these different ways.
Exactly. And then there's the whole push for biodegradable components.
Oh, interesting.
Especially for robots that might be, out in the environment. Imagine robotic pollinators that just break down naturally after they've done their job. No pollution left behind.
Biodegradable robots.
Yeah.
It's like, even with robots, we're starting to think about the whole life cycle, from creation to disposal.
Absolutely. Sustainability is key.
Okay, so we've got robots that can see, they can learn, they can heal themselves, they can biodegrade. What's next? How are we making these robots easier to interact with?
That's where human-robot interaction comes in, or HRI for short.
Okay, HRI.
It's all about making robots more intuitive, easy to use, even for people who aren't, tech experts.
Right.
One of the biggest breakthroughs is in natural language processing.
NLP.
Yeah, it's what allows robots to actually understand human speech and respond to us.
So we're talking about robots that we can actually talk to.
Exactly. We're already seeing this in social robots like EleQ.
EleQ.
It uses conversational AI to help elderly people with tasks provide companionship.
So it's like having a robot buddy.
In a way, yeah.
Okay, so robots are starting to understand us better.
Mm-hmm.
But can they actually, read our emotions?
That's where emotional AI comes in.
Emotional AI.
Okay. It's a fascinating field. Researchers are developing systems that can analyze facial expressions, tone of voice, even body language to figure out how we're feeling.
And so, how would that be used with a robot?
Imagine a healthcare robot that senses a patient is distressed and alerts a nurse.
Oh, wow.
Or an educational robot that adjusts its teaching style based on how engaged a student is.
So we're not just talking about robots understanding our words, but also, understanding our feelings.
It's about building robots that can interact with us on a more human level.
Okay, so that raises a lot of questions, though, right?
Oh, tons.
I mean, how do we make sure that these robots are interpreting our emotions accurately?
That's one of the big challenges.
Especially across different cultures,
Exactly. Cultural nuances, individual differences, all that can affect how we express our emotions. We have to be very careful about potential misinterpretations, especially if we want people to trust these robots.
It's almost like we need to teach robots to be emotionally intelligent.
Precisely. And that's a whole other level of complexity. It's not just about understanding emotions. It's about responding in a way that makes sense.
So, robots need to have good social skills, too.
Yeah. Think about it. Tone of voice, facial expressions, even body language.
Right.
They need to be able to convey empathy, understanding, maybe even a sense of humor.
Robots with a sense of humor. Now that I got to see.
It's coming.
But before we go too far down that road, we've talked about robots understanding our speech, our emotions, but what about physical interaction? Especially for things like surgery, manufacturing, where that sense of touch is so important.
Absolutely. That's where haptic feedback comes in.
Haptic feedback.
It's the technology that allows robots to both sense and provide touch-based information.
Okay.
So think about a surgeon controlling robotic instruments with super fine precision.
Right.
They can actually feel the subtle resistance of tissue through the robot. Or imagine virtual reality, where you can actually feel the objects you're interacting with.
Wow, so robots are literally getting a sense of touch.
It's happening, and it's opening up a whole new world of possibilities for how we interact with them.
So it's like we're taking all these human senses and we're translating them into the robotic world.
It's a really cool convergence of disciplines.
Yeah.
And it's not just about these individual technologies, it's about how they all work together.
Okay.
Like 5G and the Internet of Things, IoT.
Right, the Internet of Things.
They're allowing robots to share data in real time so they can work together in much more complex ways.
So like a whole network of robots all communicating with each other.
Exactly. Think about smart cities using robots for traffic management, waste collection, even emergency response.
Okay, so it's efficient, but it also sounds a little bit, I don't know, maybe a little scary.
It's understandable to have those concerns.
A whole network of robots all working together.
That brings us back to those ethical considerations we were talking about.
Right, exactly.
Yeah, it's a big topic for sure. But how about for now we kind of shift gears a bit? And we talk about how this technology is already impacting different areas of our lives, like starting with healthcare. I think that's one where the benefits are becoming really clear.
Okay, yeah, we touched on healthcare robots a little earlier,
Right.
but let's dive deeper into that. Like, what are some of the most impactful applications you're seeing out there right now?
Well, surgical robots like the Da Vinci system are already being used in hospitals around the world. And these systems, they allow surgeons to do really complex procedures with incredible precision.
Okay.
And that leads to things like faster recovery times, fewer complications.
Okay, so it's not about replacing surgeons altogether. It's about giving them better tools to do their job.
Exactly. It's about enhancing human capabilities.
And ultimately benefiting the patient.
Right.
Right.
Exactly.
What about access to healthcare? Are robots helping with that at all?
Absolutely. Telemedicine robots are making a huge difference there.
Okay.
So picture this. You've got a specialist in a big city, right? And they can actually consult with a patient who's maybe in a rural village thousands of miles away, all through a telepresence robot.
It's like Star Trek.
It really is. The doctor can interact with the patient remotely, examine them, even look at their medical records in real time.
So it's like having the doctor beamed right into your living room.
It really is breaking down those geographical barriers to healthcare.
That's incredible. What other ways are robots being used in healthcare, like in hospitals or even people's homes?
Well, in hospitals, you see robots assisting nurses with things like lifting and moving patients, delivering medications, even monitoring vital signs.
Okay, that makes sense.
Which frees up the nurses to focus on those tasks that really need that human touch,
Right.
Providing emotional support, building relationships with patients.
That's huge.
And in homes, robots can help people with disabilities with things like dressing, bathing, cooking, so they can live more independently.
It's really amazing to see how robotics is impacting healthcare on so many different levels, from, like you said, really advanced surgery to just basic caregiving.
Yeah, it's pretty remarkable.
It feels like we're really moving towards a future where robots are partners in healthcare, not just tools.
Absolutely. It's all about collaboration.
Oh, okay, so we talked about delivery robots earlier. What about agriculture? How are robots changing how we grow our food?
Agriculture is another area that's being transformed by robotics.
Okay.
We're seeing this rise in autonomous tractors and other farm equipment, They can navigate fields, plant seeds, apply fertilizer, even harvest crops, all with very little human intervention. Companies like John Deere are really leading the way here.
So robots are basically taking on the role of farmers. Are we heading towards fully automated farms?
It's possible, but I think it's more likely that we'll see a kind of partnership between humans and robots in agriculture.
Okay.
Robots can handle those repetitive tasks, the physically demanding stuff.
Right. The stuff that's hard for us to do.
Exactly. And then humans can focus on the things that require, critical thinking, problem solving, that kind of thing.
It's about finding that balance, right?
Exactly.
Yeah.
Leveraging technology to make us better at what we do.
Not necessarily replace us completely.
Right. Augmenting our abilities.
But beyond just automating tasks, how are robots actually making agriculture more efficient, more sustainable?
Well, precision agriculture is a big part of it.
Precision agriculture.
Yeah, where robots and sensors are used to collect tons of data about crops, soil conditions, even weather patterns.
Okay.
And then that data gets analyzed by AI algorithms to figure out like the optimal planting times, irrigation schedules, how to best control pests.
Oh, wow.
And that leads to increased yields, less waste.
Okay, so it's data-driven farming.
Exactly. Imagine a robot that can actually identify individual plants that are sick or stressed.
Wow.
So farmers can target their interventions really precisely, use less pesticides and herbicides.
So robots are helping us grow food in a way that's better for the environment.
Absolutely. Less water usage, less chemical runoff. It's a win-win.
That's fantastic.
Yeah.
Okay, so we've talked farms. Let's go back to our homes now. We've got our robot vacuums and lawnmowers. Those are pretty common now. But what other things around the house are robots getting ready to take over?
Well, imagine a robot that can fold your laundry, load the dishwasher, maybe even whip up a simple meal.
Okay, a robot chef. I can get behind that.
Right. Those are all areas where robotics is making progress, although I'll admit it's a little slower than some other industries.
Why is that?
Well, the home environment is tricky.
Yeah.
It's unpredictable, lots of different objects to navigate,
Right.
But researchers are working on robots that are more adaptable, more dexterous, that can handle a wider range of tasks.
So a robot that can actually, pick up my socks off the floor and put them in the laundry basket?
It might be a while before we get there, but it's not impossible.
I'm holding you to that.
Fair enough.
But what about, the whole idea of having robots in our homes, not just as appliances, but I don't know, something more? Are we ready for that?
That's a really interesting question. I mean, we've already talked about companion robots, like PARO, that therapeutic robot seal.
Right.
But I think the next generation of social robots is going to be even more sophisticated.
Okay.
They'll be able to engage in more natural and meaningful interactions with us.
So what? They could help with childcare or be companions for the elderly.
Exactly, or even act as personal assistants, managing our schedules, reminding us to take our medication.
It's interesting, because it's one thing to have a robot vacuum your floor, but it's another thing to have a robot that you're forming some kind of emotional bond with.
It's a complex issue, no doubt about it. It raises a lot of ethical questions.
Mm-hmm.
But it's also a huge opportunity to learn more about ourselves.
In what way?
Well, what is intelligence? What is consciousness? What does it even mean to be human?
Right.
As robots become more sophisticated, they're going to force us to confront those questions in new ways.
And maybe even rethink what it means to have a relationship, connection with another being, even if that being is a robot.
Exactly. It's a brave new world out there.
It really is. Okay, so one last area I want to touch on is robots in education and creativity. We talked a bit about robots being used to teach STEM skills.
Yeah.
But what other ways are they impacting the way we learn and create?
The potential of robots in education is huge.
Right.
They can provide really personalized learning experiences, adapt to individual needs and learning styles.
Oh, interesting.
They can make education more immersive, more interactive. So
Okay.
it's more engaging, more fun for students.
Right, because who doesn't love robots?
Exactly. And they can help students develop those crucial skills for the future, problem solving, critical thinking, collaboration.
Okay, so it's not just about teaching kids about robots, it's about using robots to teach them, period.
Exactly. It's a whole new approach to learning.
What about creativity? You mentioned AI-driven art earlier.
Yeah.
I'm really curious about that. How are robots actually pushing the boundaries of artistic expression?
It's amazing. Robots aren't just copying what humans do, they're creating their own unique forms of art.
No way.
Paintings, sculptures, music, even poetry.
Robots writing poetry. Okay, now you're just messing with me.
I'm serious. It's really blurring those lines between technology and art in these really fascinating ways.
So it's making us question, what is art? And who can be an artist?
Exactly. It's a really thought-provoking area.
Okay, so we've covered a lot of ground here, from robots in healthcare and agriculture, to robots in our homes, our schools, even robots exploring other planets.
Right. It's everywhere.
It's clear that this technology is moving way beyond factories and into every corner of our lives.
It's a true revolution.
So I have to ask, what's next? Where do we go from here?
That's the exciting part, isn't it? The future of robotics is full of these incredible possibilities that are just starting to emerge.
Okay, hit me with the most futuristic stuff you've got.
It really is. I mean, we're on the verge of some pretty mind-bending advancements that could totally change how we live, how we work, maybe even how we think about ourselves.
Okay, you've got my attention. Give me the sci-fi stuff.
All right, well, we touched on biohybrid robots earlier, but the progress is just amazing. Remember, we're talking about robots that actually incorporate living tissue, blurring the lines between, machine and organism.
Right, like we talked about that octopus-inspired robot made of that soft silicone. Super cool design, but not really, alive in any way. So where does the bio part come in?
It's going beyond just copying what nature looks like. Now we're talking about using the actual capabilities of living cells. Like, one really promising area is targeted drug delivery.
Okay.
Imagine micro-robots powered by actual muscle cells navigating through your bloodstream, delivering medication directly to a tumor or an infection site.
Wait, hold on. Micro-robots zooming through our veins. That sounds like something straight out of a movie.
It does, doesn't it? But it's becoming a reality. Researchers are building these tiny robots using techniques from both engineering and biology. It's like this crazy combination of microscopic scaffolding, 3D printing, even stem cell technology.
So it's like we're combining the best of both worlds, the control of engineering with the incredible power of living things.
Exactly. And what's the advantage? Precision.
Okay.
Minimizing side effects. Think about it. Traditional drugs, they often end up affecting healthy cells along with the bad ones.
Right, and that causes all those nasty side effects.
Exactly. But with these biohybrid robots, they can be guided by sensors programmed to target specific cells, so the medication goes only where it's needed. It could revolutionize how we treat diseases, especially things like cancer.
Wow. It's like having a tiny army of robots fighting disease inside your body.
It's pretty wild, and it's not just for treating diseases. Researchers are also exploring them for environmental cleanup.
Okay, like what?
Robots that can break down pollutants or clean up oil spills, powered by microorganisms that actually feed on those things.
So it's like using nature to fix the problems we've created.
Pretty much. Nature is a brilliant engineer. We're just starting to learn from it.
Okay, that's amazing.
And speaking of challenging environments, what about space?
Oh, yeah.
And deep sea exploration? Those are places where robots really shine, We can explore places humans could never go.
Right. We've seen those incredible pictures from the Mars rovers and those underwater drones exploring shipwrecks and all that. What's next?
Well, there's a lot of buzz about asteroid mining, sending robots to these asteroids to extract valuable resources.
Wait, mining asteroids? What kind of resources are we talking about?
Precious metals, things we could bring back to Earth.
Yep.
It could totally change how we access raw materials, maybe even make space travel more sustainable.
Asteroid mining. That sounds straight out of science fiction.
It does, but it's getting closer to reality all the time. And what about establishing a human presence on other planets? I mean, people are talking about using robots to build habitats on the moon or Mars, before humans even arrive. Building structures, setting up life support, even growing food.
It's like sending robot pioneers to pave the way.
It's pretty incredible, and it's all happening now.
Okay, we've got to talk about brain-computer interfaces. That one really blows my mind, the whole idea of controlling robots with your thoughts.
Yeah.
How does that even work?
It's moving fast, this technology. And yeah, it could change everything about how we interact with machines. A brain-computer interface, or BCI, allows your brain to communicate directly with an external device. It's like creating a pathway for your thoughts to control something in the real world.
So instead of using my hands, I could just think about what I want the robot to do and it would happen.
Exactly. Like telekinesis, but for machines. And the applications, wow. Think about people with paralysis.
Yeah.
BCIs could give them a whole new level of independence. Control a prosthetic limb, a wheelchair, even an exoskeleton, all with their minds.
That's incredible. Giving people back abilities they thought they'd lost. What about for other people, like in manufacturing or surgery?
A surgeon could control those robotic instruments with unbelievable precision just by thinking about it. Or a factory worker operating complex machinery, with this intuitive, almost telepathic connection.
It's like we're becoming the robots almost.
It really blurs the lines, doesn't it? And that's a question we need to be asking ourselves. Is this a good thing?
Right.
Is it the next step in human evolution? Or are we losing something essential about what it means to be human?
Big questions.
It's a conversation we need to have as a society, for sure. Like any powerful technology, there are risks and benefits. We need to approach this with both excitement and a healthy dose of caution.
Well said. This has been an incredible journey, exploring this world of robotics with you. From those tiny delivery robots to biohybrid machines, from space exploration to brain-computer interfaces, it's clear this technology is going to completely reshape our world.
It is, and for everyone listening out there, remember, you're not just watching this happen. You have a role to play in shaping the future of robotics.
That's a great point.
Stay informed, ask questions, be part of the conversation. The choices we make today will determine what kind of future we create.
Couldn't agree more. This deep dive has been mind-blowing. Thanks for sharing your expertise with us. And to our listeners, we hope this has given you a glimpse into just how amazing the world of robotics is. And a quick reminder, this deep dive was brought to you by Samurai Kaizen. Thanks for joining us, and until next time, keep exploring.